Let's move on to this question. So here the function g and f and g are defined by the following equations. Here we can see this will be a quadratic function, a minimum curve, and this will be a straight line, right? Now this will be x can take any value for those two equations. Part 1, we have to find the set of values for x for which fx is more than 15. So pretty easy, fx is x squared minus 2x more than 15. Again, that is pretty easy. We have just to rearrange it first. That will be this, minus 15 has to be more than 0. So now we have to find the critical values of x. That will be same thing. We just have to equate that to 0. That will be x times x, 5 times 3, minus 2 will be minus 5 plus 3. X will be 5, x will be minus 3. So here we have those critical values. Now we have to use that to find the range. So by looking at our number line, this is my line 0, this is minus 3, and this is the value of 5. We know the shape of the curve will be, it is positive 1, it will be this shape, right? Now we're trying to find the value more than 0, which is this and this. So which means x have to be less than minus 3, x have to be more than 5. So this will be part 1 of the question. Let's move on to part 2 of the question. So find the range of f and state with reason whether f has an inverse or not. So as you can see here, the shape of f will be something like this. We understand that because the equation is a quadratic equation and the value in front of x squared is 1, so the shape will be something like this. Now the range is the y values of the curve. As you can see, it has a minimum value. Let's find what value is that. So let's see. So we can simply find that because we can just do something here. The stationary value happens when df by dx is equal to 0. So let's find df by dx. That will be 2x minus 2. That will be 0, right? So x will be 1. Now the y value will be replaced in the equation. That will be 1 minus 2. That should be minus 1. So by observation, you can see the curve will be always more than or equal to the value of minus 1. So y more than or equal to minus 1 will be the range of the curve. So that will be part 1 of the question. Now state with reason has an inverse or not. So it does not have an inverse, no inverse, right? Because the reason why it is not a one-to-one function, that's the reason why. Again, you can write this because it is not a one-to-one function. Because if you were to draw a line here, for example, you can see for each line that we draw, we have 2 values that we get, which is not good. For a function to have an inverse, for example here, when I draw a line, I have only 1 value, and because of that, it is called a one-to-one function, and we can only have an inverse for a one-to-one function. So no inverse because not a one-to-one function. That makes sense. Now part 3. So here we have to show the equation has no real roots. So pretty easy. So first let's find g of f of x. That will be g of f of x, right? That will be 2 f of x plus 3. That should be 2 times x squared minus 2x plus 3. That will be 2x squared minus 4x plus 3. Now we have to equate that to 0, obviously, according to the equation. So now we have this. This is my value of a, b, and c. So that will be a is 2, b is minus 4, and c is 3. So let's find what is b squared minus 4ac. b squared is 16 minus 4 times 2 and times 3. That should be what? 16 minus 4 times 2 times 3, that should be minus 8. So since b squared minus 4ac is less than 0, we conclude it has no real roots. That is part 3 of the question. Now for the last one, is sketch on the graph, on the single diagram, the graph of this, of g of x, and making clear the relationship between the graphs. So as always, as you guys must know by now, there's only one kind of relationship between a graph and its inverse. It is simply a reflection in the line y equal to x. Always going to be that case. The sooner you learn this, the better it is. So it's always going to be that thing, the relationship between them. So we can draw this sketch. That'll be this y-axis, this is my x-axis, right? For example, let me draw this graph. This is simply 2x plus 3. So we understand that this is y here. So when x is 0, this will be 3. That will be something over here. And when x is equal to, let's say, what value? Let's say when y is 0, x will be minus 1.5. Let's say over here. The graph will have a shape something like this. This is my graph, y equal to g of x. Now we know that it will be a reflection in this line, so let's try your best to kind of sketch this line. It's not perfect, but you get the idea. That will be y equal to x. And the inverse curve will be something right here as a reflection to this one. That will be y equal to g inverse of x. As you can see, that was the most important thing to do, is first draw the line, then show this line, and then reflect the other line on the other side. You can always show those points of intersection as well, so you prove exactly, you know what you are doing. Okay, so these will be the question in relation to functions.